Hello, everyone. Welcome to today is February the 3rd. We're starting a new topic called Simple and Compound Interest. We are back to our regularly scheduled programming. The last couple of days, you all took an interim test, but we're back with notes and a new topic. So, hope you have it printed out. I will tell you right off the bat that this topic of simple and compound interest, it's not something we're going to dive too deep in. It's something you're going to build on more next year in 8th grade and future math classes down the road, but it is something we're just going to touch on a little bit, especially the simple interest part. And you might see one or two questions, one maybe on the STAR test, a couple questions on a future test. It's something that we do need to cover. And it still has to do with money, but here we go. Let's start. Let's start with simple interest because, well, like the name says, it's the simpler one out of the two. Let's start with a scenario for you. As a reward for good grades, you are offered $100 by your parents. That's pretty generous. They give you two options. Either take the $100 today or wait and take this $100 a year later. Which do you pick? This seems pretty obvious. Why? Is there a catch to this? What do you think? I mean, I might be tempted to take this $100 today because I immediately know I'm going to go to Starbucks probably and which stores I'm going to go to. But what about this a year later thing? Hmm. Most people would just go with the $100 today. But since we're talking about this topic called interest, there's something to do with money a year later may not necessarily be just $100. A year later, this $100 could be more. It could be $110 or $120. What I'm trying to say is with this thing called interest, a year from now, it may not be the same thing. How would that work? Let's take a look at that. Before we start, let me tell you what the word interest means. Interest means bonus or extra money. Okay, that would be the phrase. It's just a fancy word to say extra money. And where does that bonus come from? Well, let's look at this situation. Here's a bank. There's many banks, Bank of America, Chase, Wells Fargo, Capital One, all of those. So banks serve, for the most part, a couple of different purposes. Okay, the first one is to deposit money. They will hold your money. Deposit means put money in. So that means when you get a job and you get paychecks from your job, you will take that paycheck to the bank and put it into your account and it stays here. The bank is holding your money. Now, of course, these days we've got the mobile app and online banking, and we can just do it from our phone. You don't have to actually drive up to the bank, but it is an option. So a deposit means the bank is holding your money. The second job a bank usually does is give out loans. You should remember what this word means back from when we did liabilities. Remember, loan is when a bank lets you borrow money, but you do have to pay back. So these are two jobs that a bank mainly does: either deposits, that means it takes in your money and holds it, or loans, it gives out money. So today, if you take $100 and put it in the bank, that means you deposit $100. A year later, it could turn into $110. Wow, how did it do that? Where's that extra $10 coming from? That is your 100 that you're starting with plus an extra 10. This extra 10 is called interest. See, it's the extra 10 or bonus $10. You didn't do anything to get it. You just the bank kind of freely gave it to you. So we'll talk about that interest in a minute. Let's label some terms here. This $100 that you took and put into the bank to start with, that starting amount, that has a fancy name. It is called principal.
All right, Longhorns, we made it a week and
This is called principal, spelled a little differently from a school principal. It's PAL. And that is your starting amount that goes into the bank. What comes out, the 110, that is the 100, which was the principal starting amount, plus that extra, which we are calling interest. That is how that 110 is made up. So the 10 is interest. And again, why did the bank give you this extra $10? Are they just nice? Well, maybe, and also here's why. Because when you put that $100 into the bank and you leave it there with them, what they do is they will use this $100 for a year. And maybe they'll give that out as part of a loan to someone else. You know, they can't use up your money and then not have anything for you. They still need to give you back your money because it's yours. But in the meanwhile, in this gap between, the 365 days here between the day and a year later, they're using it in some way. So at the end of 1 year, they will make sure that your 100 is still there, plus this 10, which is like, thank you for banking with us. Thank you for leaving your money here with us and trusting us with it. And that's what that $10 extra is from. Now, if we wanted to go a little further and turn this into a percent, this $10, if it's compared out of 10, out of $100, 10 out of 100, to change that to a percent, that would be 10%. You could do a percent increase, percent of change formula here to get that the amount has increased by 10%. The interest was 10%. Most of the time that percent will be just given to you, but I'm just showing you as a bonus that that was a 10% interest rate. Most of the time in real life, a bank will not give such a high interest rate. Yes, 10 is considered high. It's going to be more like 1%, maybe 2%. So this is simple interest, or the story behind simple interest. You will solve simple interest for questions using this formula. There is this simple interest formula that is going to be on your formula chart when you take the STAR test. You don't have to memorize it, and here's what it is. I equals PRT. P times R times T. And if you see it, squished up against each other, PRT, you know that that is multiplication. Each letter stands for something specific. I stands for interest, P stands for principal, meaning starting amount. R is the rate as a decimal. Remember we talked about that 10% from that previous example? Well, in this formula, you wouldn't write 10%. You would write it as a decimal, which is 0.10. And T stands for time in years. It has to be in years. So watch for that. I equals PRT, simple interest formula. You will have to solve questions that look possibly like this for a quiz or a test. Let's look at number 1. Kidron deposits $1,000 into an account that earns 4% simple interest each year. Calculate the interest he earns after 3 years. Here are the 3 numbers that we need. We're going to plug them into our formula. Remember, it is I equals P R T, and we'll put each number where it belongs. P is that 1,000 starting amount. R, rate, rate as a decimal, so this 4% needs to be changed to the decimal 0.04. And T, in time, that's the 3 years. Remember, for multiplication, you can go any order. Let's do 1,000 times 3, which is 3,000, and then 3,000 times 0.04. 1, 2, 3 zeros, 12, 0, and then 1, 2, 3, 4 zeros. If I bring everything down, decimal goes there. I've solved it. The interest earned after 3 years is $120. Bonus money, extra money. All right, let's do one more. Using this little row in the table, determine the total interest in 4 years. And actually, they have kind of given us the amounts. The principal is 2,000. The interest rate is 3%, and the time in years, it's 4. They actually wrote out the whole formula already right here, 2000 times 0.03 times 4. So maybe we could skip this part and go straight to our answer. If you multiply these, it comes out to $240. All right. One more example for simple interest, just because this one has a little twist to it. Let's see if you can figure it out before I tell you what it is. It says a teacher takes out an emergency loan of $600 to pay for school supplies. How sad is that? The interest rate is 6% annually. Don't get tripped up about this word annually. That means once a year, one time a year. How much interest does the teacher have to pay after 6 months? Okay, let's write this formula. I equals P R T. P is the principal starting amount, which is 600 in this case. R is the rate. The 6% needs to be changed to 0.06. T is time, but remember it's time in years, not in months. And so this 6 months needs to be changed to, what would that be in as a year? That would be half of a year. So 0.5 is how we're going to represent time in this case. And then you solve, multiply straight across, and your answer is going to be $18. Okay, if you have any questions, that wraps up the simple interest part of this lesson. If you have any questions on that, go rewatch parts of the video, and I think it should make more sense the second time around. Let's move on to compound interest. A little bit more interesting, a little bit more tricky. Compound interest is a way where you could turn $600 into $1 million. That is not a typo. I didn't accidentally add too many zeros. It is completely possible, and you're going to find out how at the end of the lesson. So don't turn off this video. Don't change the channel. Stay with it. Let's start off with another would you rather question. Would you rather have $1 million today or start with a penny today and have it double every day for 30 days? Again, is there a catch to this? This sounds so, obvious. $1 million today, I know what I would do. First, I'd start off at Starbucks, of course, and then I'd pick some fancy shops. Maybe I'd buy a car. Or would you start with a penny and double it? If you think about that, that's just 1 cent. Penny is just 1 cent. And then the next day it would be 2 cents. And the next day it would be 4 cents because you're doubling as you go. And then 8 cents. And then 16, 32, oops, 64. We're still not even at $1. We're still at 64 cents. I think at this point on 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. On the 8th day, we do cross the dollar mark, and I think that becomes $1.32. No, that becomes $1.28. Okay, so based off of this pattern we're going, it still seems like the $1 million today would be the obvious choice, but is it? I don't know. There might be a catch to this. I am going to link this video separately in your module. Watch this. This one's going to answer that riddle. $1 million today or a penny doubling every day? This is going to tell you the answer to that question, and you actually might be shocked at what the answer is. So go watch that. Don't skip out on that. There is a compound interest formula. As you can see, it's much trickier, more complicated than the simple interest formula. There's a lot more to it. All you need to know for this year right now in 7th grade is just what it is and what these parts are kind of labeled. I don't think you're going to have a question like this on the STAR test or many compound interest questions at all, because there are parts of this formula that, such as these exponents here, that you have technically not been taught yet. This is something you're going to build on more next year in 8th grade for sure, and definitely beyond that. So just label the parts. A stands for amount, total amount. P stands for principal, like before, parentheses, 1 plus R is rate still as a decimal, over N, this N is new. Number of times interest is compounded per year. That same N, that same number that's here also goes up here as an exponent, and then T is still in time. Okay, just label the parts and we'll use it. Use the table to calculate compound interest with a principal of $2,000 and interest rate of 3% for 4 years. This is actually going to be simple interest, but I will show you at the end how it kind of links to compound interest. So let's work through this. If you start off with $2,000 as your principal or starting amount, interest rate of 3%, which is 0.03 for 1 year, the interest earned is going to be, you just multiply everything, right? Like the old formula we did, 2,000 times 0.03 times 1. If you plug that in, multiply straight across, and I think you're going to get 2,000 times 0.03. You're going to get $60 interest earned. What you're going to do is take this interest, add it on to the previous, so you had 2,000 to start with, plus you earned this extra $60. So on year number 2, this would be year 1. Year number 2, you are not starting off with 2,000 again. You're starting off with $2,060, right? Your principal and your interest. And then you're going to calculate this thing all over again. This time you're going to put 2,060, 0.03, 1, multiply that across, and you're going to get $61.80. So at the start of year number 3, again, you are starting off with, well, you had 2,060 plus you earned a bonus 6180. That's going to be 2,121.80. Okay, you can finish up this table at this point. Try it on your own and I will fill it up myself. All right. At the end of year 4, you are now sitting at, well, at the end of the year of year 4, you are going to do this amount that you started the year off plus that bonus. That's going to be 2185. You're going to be at $2,251.01. Okay, what we did, you will again not be asked to do a question like this on a test. You won't be asked to fill out a table. But how does this relate to compound interest? What we did over here actually is simple interest, right? Just PRT, PRT every single time. This was actually principal interest. But we had to do this for 4 separate years. We did 4 rows individually, and it was really kind of time taking. This is where compound interest comes in, that formula. That formula lets us just jump straight to, plug in into the more complicated formula. And instead of having to do each individual year, you can just plug in and jump straight to the same number in one step. So that's the compound interest formula. You would put the principal right there. You're starting at 2,000. 1, the 1 stays. The rate is 0.03. It is compounded once a year. So that would be 1 for n. And the n would be 1 again, times t, and t, this was for 4 years. So you would just plug and solve everything, and you should get the same answer as doing simple interest 4 separate times. You should get the same answer. So this is where compound interest, it helps you jump all these rows. And if it's 4 years, it lets you calculate the 4 years in just one step. Again, like I said, you will not have to use this compound interest this year in 7th grade. You just need to know what it is and kind of what the parts are, and maybe just in relation to simple interest what that is. That's it. So we're kind of done with the math part, and here's a little bonus. I told you we'd answer this question: how to turn $600 into $1,000,000. Open up another tab on your computer, follow these instructions, and we'll calculate this. Type in Google, type compound interest calculator. I think the first or one of the first or second results you'll get is nerdwallet.com. So click on that. And that should lead you to a page that looks like this. We're going to put some numbers in and see what we get. Here we go. My screen is pulling up. And when it does, it should look like this. All right. Remember, we're trying to see how do you turn $600 into $1,000,000. Let's start off with $100 in the bank right there. $100. That's not a lot at all. Also pay attention, simultaneously look at the left, look at this chart on the right, and see how it changes. Let's do where it says contributions, let's bump this up to $600 monthly. Select monthly. What that means is in your bank account you're starting with 100, and then every month you're adding to it $600. And then we're going to go to this time section. Time, let's do 30 years. Bump it all the way up to 30. You can see on the right that the graph is changing a little bit. Okay, so starting off with the 100 and then adding $600 a month to it for 30 years. Now we're going to do the important number here, the interest rate. Remember, we've been talking about interest rates. Let's set this at 10%. Just a nice doable number. Keep watching on the right side. And we're done. Look at this number that we have ended up with. All right, I'll explain what's happened. We have turned $600 a month into $1,187,000. And again, this is not something you'll see on a test. This is just a little bonus for you. Let's look at this blue part of the graph. This blue part of the graph represents you starting off with $100 in your bank account. I bet a lot of you have that much, if not more, maybe in your piggy bank, or you probably got that much for Christmas or something. We started off with $100 in your bank. The blue represents every month you adding $600, to that account. Every month, 600, 600, 600. And at the end of 30 years, if you add up all of those 600s, at the end of 30 years, what you put in is just, it says here, total principal is just 216,000. That's all of your 600s added together. But if you look at the green, that is all that bonus money that comes from compound interest. All bonus, all extra that's added. All the extras, all that interest together total, you can see is $970,000. So together, if you add up everything, what is sitting in that account at the end of 30 years is over $1,000,000. That's how you turn $600 into more than $1,000,000 technically. So, pretty interesting. I think you can play with that website some more. You can plug in some other numbers and change it up and see what you get. All of that may be a lot thrown at you at once. At the end of the day, though, at the end of today, here's what I want you to be responsible for. You only need to calculate simple interest today using this simple formula. I equals PRT. You will not need to solve compound interest this year. Just know that it's possibly an interesting topic and you will see more of it next year. Okay, so that's it. You're going to do a homework that's related to this formula and this one only, and I will see y'all next time. Bye-bye.